Hi, good morning. Can you hear us?
Yes.
Okay, great. Let me shortly show the agenda. So what can I share? So, okay, today we have 4 topics. First, we will hear from Swapnil about FTD optimization. Then George will present the dependency watchdog.
But yes, there is a.
And then we have.
You are hardly audible. There is a lot of noise.
Someone talk. And we have 2 updates on extensibility. Axel will talk about worker and infrastructure extension resource. And Tim will talk about extension resource for the certificate service and other generic extensions. So, do we have any other topics? If not, then Swapnil, you can take over.
So, share the screen. Okay. Everybody, I hope my screen is visible to everybody.
Yes, we can see it.
Yeah. Okay. Hi. So, yeah, long time we haven't updated much about Excel or Excel backup restore as such, and we thought of collectively present the whatever optimization or related work we have done related Excel. So, main target was earlier we used to fetch the Excel too long Excel downtime while updating Excel stateful set or maybe Gardener where Excel version or Excel backup restore version was getting updated. So main effort was regarding that. So some notable updates on Excel backup restore with latest release. These were actually part of Gardener 0.22.0 release of Gardener, but since then we didn't have meetings, so sort of presenting. So first thing earlier, okay, on Excel we used to have data directory validation. So this data directory validation involves some sanity validation like data directory structure, whether it is very well, the snapshot revision and current latest revision are in order, such kind of checks, and DB file content check itself. So most of the checks were DB dependent. So these were so we categorize them as like sanity checks and full data validation checks. So whichever the checks which are DB size independent, which will take constant time, were part of sanity validation. Mostly the bold DB file or snapshot file that Excel creates in data directory. These involves the bold DB checks, which are data DB size dependent and which were consuming too much time for a large data size. Maybe we have seen 3 minutes times for a large DBs. So, what we do is we now, as a part of Excel Bootstrap script, we note down the last Excel's last exit status, and if that is success, like graceful deletion, we say okay, Excel might be terminated because of the pod rescheduling or update event. In which case the Kubernetes itself we get an event that delete Excel pod. So in such case we mark validation marker with Excel status, and since Excel status with graceful termination, we just do sanity validation. So next time when Excel is started, we don't do entire DB file check, and this optimizes on time. And in other case, if we really found that Excel DB is corrupt and there is some erroneous exit code, then we do full validation check, and it might take time. So this was one of the optimization. Then regarding readiness, though once Excel is restarted, we used to take a full snapshot of Excel, and then only we used to mark Excel backup restore as healthy, or eventually Excel as ready to serve to API server. till that time, headset was unready, so API server used to get in crash loop backup because of headset unavailability. Now, thanks to Shreyas coming with idea that we take a delta snapshot initially, which was basically we start a watch on headset from the latest last revision on latest snapshot, and we take a delta snapshot. There will be hardly any update on this time, and this delta snapshot time is very low. And post that we take a mark headset as ready, so API server can load headset with further traffic, and then we take a full snapshot. This way we assure that there is no data loss at all or across restart as well, and the headset is ready earlier. Then okay, next stuff was regarding wall verification. So as I mentioned earlier, as a part of validation, data directory validation and verification, we had wall file verification as well. So for this, initially on headset, there was an API which used to load all wall files that is write ahead logs created by headset in memory, and then check whether it is correct or not in right shape or not. This was so in that case also by default headset has hard coded it to 64 MB each wall file, and it is configured to have 5 snapshots, and these were 5 wall files at max. And as the headset gets the load, the data is returned to write ahead logs, and these wall files are created. If there is some sudden load, let's say possibly we faced with IT or our end-to-end cluster, or if for some, I don't know, for some scenario, if there is sudden load in short time, there is too much load on headset or rather Kubernetes cluster, then you could see under headset data directory there are too many wall files, and since headset garbage collection of these wall files take times maybe 30 seconds, sometimes these wall files persist in headset. And in that period, somehow if headset gets crashed out, then headset backup restore comes in picture, and it tries to verify. And then we have seen that there was too much memory consumption in wall file, and sometimes it used to get home killed. So for that, Shreyas has already raised a added. We needed change on upstream headset where we needed some memory optimized API for wall verification from headset, and that was merged in upstream headset. And since then, we have seen that wall verification takes constant time less than 15 MB, constant memory less than 15 MB. Earlier, it was loading all wall files in memory. Now it is loading only required a single wall file at a time and processing it entry by entry. So there is less memory consumption. Okay, these were updates on headset or headset backup restore regarding the functionality. Then, okay, now next topic was regarding the storage class migration. Okay, so okay, we know headset is highly headset requires okay, headset performance is highly related to disk IOPS. So earlier, Gardner used to Gardner used to have default storage class for the PVC that was a part of headset stateful set. So now then we faced some disk latency issues, and we were observing throttling issues while monitoring disk performance. So we wanted high IOPS. So in this we have so with this change we basically introduced new storage class called named as Gardner Cloud.fast. Basically this storage class points to the fast disk with high IOPS per cloud provider. These are SSD disk or a flash disk depending on the cloud provider, and the disk sizes are again varies as per the cloud provider's specification. So those are calculated based on the as a trade-off of cost and number of IOPS we wanted. So this change was introduced with Gardner release 0.22, where it said in that change, basically we'll now have two PVC attached to headset stateful set. One is the default storage, one PVC with default storage class, which has old headset data, and one will be the new PVC, which is pointing to this Gardner Cloud -fast storage class. Okay. So now we wanted etc to store data with new PVC. So we wanted data to be migrated to new PVC. So I'll just plus explain how do we do it. So basically, as a part of etc bootstrap script, we will copy the data from old PVC to new PVC, and on complete this is disk to disk copy, basically simple CP command, and on completion we create a migration marker file. So in further restart, we should not take any action regarding migration, and etc should work with data directly in new PVC. So reason for this approach was, okay, we know etc backup restore, even if we simply replace the PVC, once seeing empty PVC, etc backup restore solution will come in picture and it will restore from latest snapshot. But again, restoring over network might take too much time, and this change will we wanted this to be optimized, that disk to disk copy was faster compared to this restoring from old snapshot over network. So for this one-time change, we thought, okay, we'll go with this approach. Okay, said that though we changed the storage, the PVC storage class for etc main, on etc event comparatively, we were fine with the default storage class, and we didn't want it to have too much spend cost over provisioning PVC with high ops. So we still have default etc events stateful set with PVC with default storage class. Okay, this is okay. This is what changed. What changed in 0.20.0 Gardner release. Now post that, okay. Now okay, we have two PVCs in cluster, out of which one PVC is basically idle, the old volume associated with old PVC. So we have already written cleanup code to delete this old volume old PVC and old volume, and this is already merged with master, but somehow because of communication, we'll probably will have it as a part of next release. Since then, again, the etc will have only one stateful etc stateful set will have only one volume claim template, that in which the storage class is pointing to new the past disk. Okay, so this change will affect take post 0.24.0 or probably next release. Okay, the only catch with the migration thing is there are two cases. One is a hibernated cluster. So okay, for hibernated cluster, we scale down the etc stateful set. So basically etc pod is container or pod is not running, so migration script is not running. Though etc stateful set is changed, the data is still in old PVC. So for that, user need to shoot owner need to come and disable the hibernation, and then only hibernation migration will happen. But for that, as George helped us writing the helper script, in which without user action for hibernated cluster, we will directly scale up etc stateful set, let migration happen, and scale down the etc stateful set. There is from user side, there is no action required. This is we expect this script everybody to run this script in their setup, but this is again optional, since okay, even if we post the, because the cleaning up old PVC PR doesn't consider hibernation case in mind, that whether old migration happened or not, it simply deletes the old PVC. So post this script, okay, we were sure that migration happened and new PVC has the data directory from old PVC. But okay, again, this is a recommended script, but since optional, since etc backup restore will anyways after seeing the empty disk, it will restore from latest snapshot, and there won't be any data loss. For shoots with disabled reconciliation, shoot owner has to explicitly enable, because we don't know when was the reconciliation disabled and what is the state of the cluster. So somebody has to operator has to explicitly take care of those clusters. Okay, so these were the updates so far. Thank you. Any questions? Cool.
Thank you, Swapnil. It seems there were no questions for your talk. Then we can go to the next topic. George, you can take over.
Yes. Yeah. Let me just share my screen. Okay. I hope everybody can see my screen.
Yes.
Okay. So what I'd be presenting today is a component called Dependency Watchdog. First, I'll explain why we need this. So when etcd, okay, there is a dependency on etcd by Kube API server and the other control plane components like the KCM, the Cloud Controller Manager, and the other components, they have a dependency on the API server. So if etcd is down, then Kube API server goes into a crash loop backoff, which would chain an event of crash loop backoffs for the other control plane components. So what we wanted with a dependency watchdog was as soon as a dependent service is up and running, all the dependent pods on that service, if they are in a crash loop backup, should be short and they should get resurrected back at the earliest. Because if they are to be in a crash loop backup, there would be instances that it would take as long as 5 minutes for the pod to restart or the container that's in the erroneous state to restart. So with that in mind, I'll explain how the structure of the dependency watchdog. So here, this is the config file. In the config file, we'll have a config YAML that is read by the dependency watchdog, which lists out the dependencies. So if you can see here, I have this map called services, which has two services, the etcd main client and the Kube API service, the API server service. The etcd main client has the API server dependent on it. So I use this selector to hone down on the API server. Similarly, for Kube API server, I have the other control plane components dependent on it, but I have removed the etcd main component and the API server component. So this basically means that when etcd main client comes up, if the API server is in crash loop backup, it should shoot it. And if once the API server comes back up, it should shoot all the other control plane components that are in crash loop backup. Now let's go to a demo. So if let's see, this is a cluster that I have run, and I have scaled down the dependency, already existing dependency controller in it, so that I can run my controller locally. So here, if you see, the Cloud Controller Manager is in crash loop backoff. Kube Controller Manager is in crash loop backoff. Scheduler is also in crash loop backoff. Sorry, API server is in crash loop backoff and controller manager is in crash loop backoff. This is because we don't have the etcd running. So first, what I'll do is I'll scale up etcd, and I'll run the dependency watchdog. So here I am running the dependency watchdog. I hope everybody can see the logs. Now I'll increase a replica of etcd main. And I'll keep a watch on the pods. So here the main the container is getting created. So ideally what should happen is once main comes up, it should kill the API server. The dependency watchdog should kill the API server, which should then restart the API server. Okay, so if you see, the dependency watchdog has killed the API server when etcd main has come up, and once the API server comes up, it should kill the other components. So here the API server is coming up. Yeah, so once the API server's endpoint comes up, it should kill the other parts of it. So how it works is when the API server starts running, the readiness of the service. Yeah. Okay. Now, if you can see, as the pod has come up, it had killed the controller manager, which was in crash loop backoff, and the kube controller. Yeah. So what has happened is the dependency watchdog has killed the dependent pods, and it will come back up. Now, how it works is when the service becomes ready, the endpoint is assigned an IP address, and once the IP address is assigned, the dependency watchdog checks on the dependent pods, and if they are in crash loop backup, it just shoots it. So now you see that all.
So you mentioned about the period in which this watch is maintained after the endpoint is ready.
Yeah. So the inputs to the dependency watchdog is basically the watch duration over which the dependency watchdog should check on the endpoints and shoot the pods. So what we do is once the endpoint is ready, the default is 2 minutes. We watch the pods for 2 minutes, and during this time, if we see any of these pods go into crash loop backup, we kill those pods. But it is a configurable parameter. That's it. Hi, Matej, that's it from my side.
Are there any questions? Okay, seems not to be the case. Then next one is Axel.
All right, let me share my screen. In a second, I need to before that set up my presentation. All right. So I'm today giving you a short update, short progress report on what we've done with regarding extensibility. In specific, I'm today talking about the new infrastructure and worker resource. So first of all, we'll talk about the infrastructure resource and why we introduced it. So currently, this infrastructure resource is a new CRD that's being deployed to all seeds. And the purpose of this infrastructure resource is it should represent infrastructure characteristics that shall be deployed on a certain infrastructure, of course. So, for instance, in AWS or GCP, it manages the creation of VPCs, subnets, whatever. Among all the, but still we enforce some common fields across all infrastructures. So as you can see, the required fields that we have across all infrastructures is, of course, the type. Type means, in this case, AWS, GCP. The region in which this infrastructure is being hosted at, the SSH public key, which is important for setting up some resources inside that infrastructure. And last but not least, secret ref. This is being auto-set by the gardener and points to the secret of the cloud provider that the infrastructure reconciler shall use to create those infrastructure resources. Since you see that this is basically not enough to represent all provider specifics, each provider is also able to provide a provider config raw extension containing its specifics. And if you're asking yourself now, like, okay, who's creating this infrastructure resource right now in our seats? For now, before we change our shoot API, the gardener takes care of converting the existing Terraform infrastructures to the new infrastructure resources. But as part of the general extensibility, we will also have to think about how we can migrate this so every user is able to, also to which degree a user is able to specify characteristics of the infrastructure resource. Just to give you some idea of how this looks like, so I've extracted how an infrastructure resource looks in my cluster. So we can see in this specific example, it's an AWS infrastructure. So you can see I'm providing the region as set, the public key, and the secret reference. And the provider extension, you can see that this is like a raw blob at first glance inside your infrastructure resource. But inside this raw blob, the provider again takes over validation and makes sure that those fields are set properly. And once you and if you specify those fields, the specific provider will take care of setting up the VPC in this case and setting up the zones as requested. Yeah, if you're asking yourself now, like, okay, how can this be implemented? In our Gardener extensions repository on GitHub, we already have some common libraries for setting up all the for implementing a custom infrastructure controller. So and in this library, there's also a common reconciler that provides already setting up the correct Kubernetes API server watches plus the finalizer handling. And you as an implementer of such an infrastructure just have to implement an actuator interface. And with this actuator interface, you just have to make sure that whatever you have in your custom provider spec, you create the appropriate infrastructure in your backing cloud provider or wherever it makes sense. And yeah. Okay. Next of all, I'm going to talk about the worker. So maybe also just a short disclaimer. I'm going to talk now about the resources, and then I'm going to show you how they look in a live system. But I just want to give you like the rough introduction of how this all looks like. Yeah, worker. Why do we have the workers? Those are CRDs again to represent worker groups per cloud provider, and usually. Like that's basically how we do it in our reconcilers and actuators. We just translate them to machine deployments via some mapping. And the common fields that are in all the worker resources are the infrastructure provider status that closely links to the infrastructure resource we had before. Like the worker depends on the infrastructure to be correctly up to date, and once this is up to date, the provider status of the infrastructure is being copied into the worker resource, where then the worker reconciler can extract the required fields for its own reconciliation. It also has a field called pools, and inside each of those pools, you specify the machine image, machine type, like you used to know it from the shoot spec. Also, like what I omitted here is also stuff like max search, max unavailable. If you want to do rolling upgrades, you specify the user update, the volume, the zones. And as for the others, we also have the region, the SSH public key, and the secret ref pointing to the secret that the worker actuator or worker controller should use to create your worker resources. Just again, to give you some idea how this all looks like, you see here that we have the pools. I've just extracted one of them, where we specify, okay, we want to have a machine of type Chorus and with this version. As you can see, in contrast to our existing or to our previous shoot API, it's not like name to AMI, it's name to version. That also goes hand in hand with another, I think I documented it. Yeah, I documented it later, sorry for jumping, and I will also come to that, but we have some breaking API change in our cloud profiles that I will also talk about. But to just make it short, we wanted to have our machine or the API here a bit more declarative, because this also allows us for greater degrees of flexibility, but also allows us to reconcile more gracefully, I would say. All right, yeah, again, custom implementations are, again, easily possible via a library that we have in Gardener Extensions, where you basically just have to, in short, you have to do a bit more than that, but in short, you just have to provide a provider mapping from machine type plus version to your, for instance, AWS AMI. And yeah, that's really just in short. You have to do a bit more than that, but it's not that difficult to implement a worker resource. Okay, now I'm going to come to the demo. So let's switch to my command line here. So what I'm trying to do now is I'm applying a shoot. Okay, I'm applying the shoot, and I'm going to switch to the kubeconfig of my AWS. Let's see, get. We already have an infrastructure. There you see. Now we see the new infrastructure resource. YAML. Yeah. That's basically how the infrastructure resource is. Under the hood, it still has the old code that does the Terraform apply. And we're also for existing shoots with the non-infrastructure resource, we're migrating the state and making sure that nothing breaks for you. But yeah, as soon as this infrastructure is basically done reconciling, this might take a while. You should see that. This might take some time. Might maybe. A bit too long for the demo, but as soon as this is basically done, the infrastructure status will show the created VPC and the created subnets, and then the worker resource can basically jump in and start with the further reconciliation. I'm now going to jump back to my presentation, but maybe we can revisit it later and have some luck that it is done doing its job. Okay, last but not least, that's basically what I hinted at, is we're also having a breaking change in the Cloud Profile API. I think we also notified some of our stakeholders already. And as you can see here, the configuration is different from this old API where you basically define a mapping between machine image type and AMI per region. We now have this new, more declarative API that specifies the mapping between name and version. And if you're now asking yourself, okay, who's now doing this other part? Who's mapping the version to the AMI? As said, that's now part of this worker controller. And if you wanna have this correctly set up, you're gonna have to correctly configure your worker controller to contain this mapping between version and AMI. Let's see, maybe we had some luck and this thing is done. Okay, no. Yeah, I think that might maybe take too long, but I think that's already like quite a good look into what the resources do. As said, inside those things, there's probably not much more. Ah, yeah, we were lucky. Right on time. We see it. Yeah, there we can see it. It's created with the infrastructure, the VPC with this ID, these security groups, these subnets. Maybe now I'm also lucky and can get the workers. Let's see. I think this doesn't look that good. The workers are not there yet. Okay, I think that maybe takes too long for now, but yeah, just that you know, the infrastructure controller is now an own controller that runs inside our seed and reconciles our infrastructure. Same goes for the worker controller. And yeah, unfortunately not there yet, but still, yeah, thanks for listening. And if anybody has some questions about what we're doing here, just feel free to ask.
Okay, thank you. If there are no questions, then we come to the final topic. Tim?
All right. So let me continue where Axel stopped. And this is with the extension resource. So just for a short introduction, Axel just has showed us resources like infrastructure and workers. These are resources you definitely want to have in your shoot cluster, because when you create a shoot cluster, you definitely want to have an infrastructure, you want to have workers and so on. But there are also some generic cases for which we don't have any specific resources. And these use cases are handled by the extension resources. So for example, in our case, or what we do at the in the Gardener team is that we have some kind of certificate service for shoot clusters, and we don't define that as a hard requirement, because you don't want to have a certificate service for every single Gardener instance you host or you have installed in your environment. So therefore we defined, okay, let's take this as an so-called extension. And yeah, so the extension itself, as I said, is nothing more than, as well as the worker and infrastructure, it's a CRD. And for example, if you have a use case like we have for the certificate service, we would need to register a controller which handles the certificate service. So let me walk you through the documentation which we're going to have in place in a few days in the Gardener repository. So it could all start with a controller registration for your controller handling extension resource. So you would define a name for it, and you would also define that it's of kind extension. And then you have the choice of the type you want to handle. So this is an example, but let me switch to the certificate service. And here we would define the type as certificate service. And last but not least, we have another field that's called globally enabled, which means that if you want to have it, or whether you want to have the extension resource available for all shoot clusters or only for specific shoot clusters. For example, if it's set to true, then the extension resource will be available for every shoot cluster that is controlled by your Gardener instance. For example, here again, for the certificate service, we, for instance, can say we want to have the certificate service for every shoot cluster, so we just declare it as globally enabled. Okay, so once you have that in place, and the shoot itself enters the shoot flow, for example, the creation flow, then the Gardener takes care about placing such an extension resource to the seed cluster more specifically within the shoot namespace in your seed cluster. So here you can see just an example for an extension resource. It's of course a kind extension, and in the spec we can find the type as well as a provider config. So let's imagine you have that extension resource in place in the shoot namespace in your seed cluster. Then the controller in the seed would kick in, handles or reconciles that extension resource, sets a proper state or sets a proper status to the extension resource, and then Gardener just checks the last status, and as soon as this was successful, it could continue with its reconciliation of the whole shoot. So general contract is Gardener places the extension resource, and then finally Gardener continuously checks for the successful reconciliation of this extension resource. So just a small add-on that we have in place. So I already talked about the provider config, because there might be some cases where you want to place some data into the shoot manifest, and you want to have this data also being pushed to the extension resource. And this is exactly the provider config. So when you have a shoot manifest, and then there's in the spec there's an extension object. Here again you have to specify the type, example or certificate service, and you can define also a provider config. So and this provider config will be reflected in the extension resource here, so that the controller responsible for this extension resource can process that information. Right. Yeah, okay. And here, as I already mentioned, then the Gardener only checks at the end if the last operation is succeeded. And if this is the case, it will continue the shoot flow, or can finally set the shoot flow to succeeded as well. Okay, I think that's the general overview of the extension resource. Are there any questions?
Do we like to use that, for example, to move out monitoring, logging, and into separate controllers, instead of having that inside the Gardener repository? Or could we use that for that?
We could use that for it, yeah. For instance.
Cool.
So whenever we decide the use case is generic enough to use the extension resource,
yeah, but then you could make things like monitoring, logging, audit logging, whatever. You could make it pluggable.
Yeah, definitely.
Yeah. Cool.
Any other questions? Not to be the case. Do you have any other topics you want to discuss today? Everybody's looking forward to the weekend. Okay, thank you. See you next time, next week. Bye-bye.
Bye-bye.
Bye.